Welcome to Tset. In these demo calculation videos, we want to demonstrate to you how Tset cost carbon works and what exactly it can do. In this particular video, we're going to focus on machining. So let's get started by adding a new calculation to our project. This takes us to the first page of our calculation creation wizard. Here, we must first enter our part name, in which case we'll go with a helical gear, and if desired, a part number. Then we have some of our basic preconditions, such as the lifetime, the average volume, the peak volume, and the location, all of which are mandatory for the calculation wizard. If desired, the calculation can be changed from the default value of purchased to an in-house calculation, which would then be without any additional overhead rates. It is also a good idea to copy-paste or drag and drop an image of your part, and of course you can also upload drawings and other documents. In the next step of our wizard, we need to choose the technology we wish to use for our part. In this case, we are calculating a forged helical gear, and so we will select die forging steel technology. In order for our automated calculation module to function properly, it now requires that we enter the weight of our part, and we must also select the desired material. This information is usually available on the drawing or specifications of the part. The next step of the wizard shows us a selection of different shapes that have been filtered to match the technology, weight, and material that we just entered. Simply browse through the shapes to find the one that best resembles your part. In our case, this would be shape number S284. Now we come to the technology-specific parameters section of our calculation creation wizard. Please note that these parameters may vary depending on the technology chosen. Our first field is the heat treatment type of the forged part. We offer a selection of different heat treatments, but for this part, normalizing would be the standard. Then we have our tolerance field. Here we will select standard because this part will actually be machined after forging. Cold calibrating is not necessary in our case. And then we have a very important field called machining. We wish to use an automated calculation for machining as well, and so we will select turning. This also activates the margin field. For a hot forged raw part for this size, a 3mm margin is usual. Cleaning for the raw part is not necessary since it will be machined anyway. Crack testing is also not needed for this part. An additional 100% inspection beyond our usual checks is not necessary for this part. The main dimensions are already pre-filled according to the selected shape and weight. However, these can of course be overwritten if, for example, you have the exact dimensions of the part from your drawing. Because we selected turning as our machining operation, we are now taken to the turning sketcher wizard. Here we can either use the contour of our pre-selected shape as it is, or we can adjust some minor dimensions to match our specific needs by selecting and dragging different points on our sketch. When we're happy with our shape, we can then choose from several surface operations, quality, and hardening types of our finished part. In this example, we are going to set the global surface finish to turned, with a surface quality of RZ12. We would like our part to be case hardened with a hardening depth of 0.8mm. The radius on the edges of the part should not be larger than 1mm. Next, we will make some changes to individual surfaces. The outer diameter of our parts needs to be geared. All the specific parameters of the gear are shown on the drawing or the gear specification. In this case, we will select the surface that has to be geared just by clicking on the respective line and then we enter the details from our drawing. For example, our operation type will be set to geared. The type of toothing would be helical gearing. The module would be 2 millimeters. The number of teeth would be 95. Our pressure angle is 21 degrees. And our helix angle is 19. The inner diameter and one of our faces must also be hard turned after hardening, with a surface quality of RZ6. Please note that it is also highly recommended to download the sketch at this time using the download button at the top of the sketcher. This can save time and effort should you encounter any errors or if you wish to calculate a similar part later on. In the next step, we can now double check all the parameters and calculated values and then simply save the calculation. And now we can see that Tset Cost Carbon has created a detailed bottom-up calculation for the cost and CO2 footprint of our part. The calculation itself is fully editable in every detail and uses verified cycle time calculations and estimations on tooling costs. The entire calculation and cost breakdown can be viewed with cost or CO2 values at any stage, simply by activating the toggle switch at the top of our screen. On the left of our screen we have our BOM Explorer, which shows us that all the required process steps have been calculated automatically. When we navigate to our Manufacturing tab, we can quickly analyze all the necessary cost blocks of the manufacturing processes of our finished part, and of course identify the main cost drivers. If we open the details page of our raw part turning step, we can see that all of the required cycle time steps of turning the raw part have been considered and calculated in detail. Various costs such as system, setup, and labor have all been included. Our cutting tools have also been automatically calculated and added here. Scrap and residual manufacturing costs have also been included, thereby completing the cost calculation for this single manufacturing step. Indeed, every single manufacturing step is calculated to this level of detail. If you would like to receive more information, please visit tset.com and reach out to one of our experts.